Hi guys, welcome to my channel, The Analyst. Today we'll perform a demo for logistic regression. The dataset that we'll be using is the German credit dataset. I'll attach the link in the description. So let's jump right in. As usual, I clean up my environment, then I read the table. Let's have a look at the table, okay? If you see over here, the credit data has 1000 observations and 21 variables. The last variable being the target. If we have a look at the target, it's in ones and twos, one indicating a good credit risk and two indicating a bad credit risk. Since we're doing logistic regression, we will have to get it into the 0 and 1 format. To do so, I will just pick up the last column and I'll minus 1. So 1 minus 1 will give me a 0 and 2 minus 1 will give me a 1. So that's what I do over here. 0 good credit, 1 bad credit risk. Now the next step is to split my data set into train and test. I will use 70% of my data to train and 30% to basically test the model. Here we'll have two models, and what I'll do is that I'll compare both the models in terms of their performance. What we'll realize from this demo is that accuracy of the model is not everything. Sometimes you also have to have a look into the data set and understand exactly what they are trying to predict. In this case, in the credit data set, it's really important that you predict someone to be a good credit risk properly. Because if you predict them to be a bad credit risk, good credit risk when they are not a good credit risk, what will happen is that you'll have a lot of non-performing assets, which is bad for you, right? So we have to set the correct thresholds while predicting. Anyway, we'll get to that in a little. Let's have a look at our first model.glm. 21 is my target, V21, like shown over here, V21, and I train it over all my predictors, all my variables. I use the family binomial because I'm doing logistic regression and the link is logit. I have a summary over here, use a summary function, and as I can see from this, I'll come to know these are my p-values, okay, 0.5, 0.6 and so on. From here what I can see is that I have a lot of variables, however not all of them are important to construct the model. Okay, so if you scroll a little bit down, you'll see significant codes. Here basically the most significance is given by more stars, and basically if you have a lower p-value, it is more significant. So I'll pick everything with 3 stars, 2 stars and 1 star. I'll leave out the rest. So I'm picking only those variables that have a p-value of less than p less than 0.01. I'll pick this up. This also is pretty good. Okay, it's not really less than 0.01, but it's fine. I'll pick these. So everywhere with the 3 star, 1 star, 2 stars, I will pick them up and form model 2. So again, my target is V21 and I've picked up only those variables that are of importance to form the model. I'm using the binomial family since we are doing logistic regression, and I plot the summary of model 2. Okay. Now, how do we come to know between model 1 and 2 which is the better one overall? Okay, at one look, there's something known as AIC, and the lower the AIC, the better the model. So for model 1, the AIC is 739.32, while as for model 2, if you see, the AIC is 733. Okay, so model 2 on first look is better. overall. All right. Now let's see. Now we have two models in place. We'll now predict. We'll we'll use this model and see how well basically it can predict on our test data. So I'm using model 1, model.glm. I'm feeding in the test data and I get a predict object. Okay, the predict function is basically that I use. Now basically I have my predictions in PR1. Now whenever you use the predict function, you don't really get values in terms of only 0, only 1. It could be anywhere between 0 to 1. It could be 0.5, it could be 0.623 and so on. But however, for logistic regression, we need the values to be either 0 or either 1. In that case, what I'll do is that I'll pick a threshold and I'll say that anything above this threshold, you have picked 0.5, so 50%. Okay, anything above 0.5 means that I will make it 1. Anything below that is 0. So again, 0 is good credit risk, 1 is bad. That's what I do over here, and I put it in the form of a table, a confusion matrix. Okay, I check the accuracy and I get an accuracy of 0.75 for model 1. Pretty decent. Now let's have a look at model 2. For model 2, the test data is only supposed to have the variables that I've considered while forming the model. So I basically form my test. I picked only those variables up. Here is basically my data, okay, my test data, and I feed that to model 2, model.glm2. Now again, same way, I'm using the predict function. Anything above 0.5 is classified as 1, anything below it is 0, and then I plot my confusion matrix. Now I check for the accuracy. Accuracy is nothing but I take the sum of the diagonals over sum of all the values, and I get 0.78. So I get a better accuracy in this case. However, see, now whenever we are looking at any data, it's very important to understand what exactly that data signifies. In this case, we are having a look at, overall we see that model 2 has a better accuracy. I agree. Okay, but the fact is that we also have to have a look at the true positives. Okay, so true positives is basically that given that you have predicted that it is a good credit risk, it is actually a good credit risk. And false positives is given that you predicted that it is a good credit risk, it is not a good credit risk. The number of false positives is supposed to be low in this case because of the high impact it can have when you classify someone as a good credit risk and they turn out to be bad. So what we'll do is that we will basically check that for each, this would basically vary on the threshold that you set. Okay, let's vary this threshold from 0 to 1 and check the false positives and the accuracy for that particular threshold. So I basically written code over here which will vary the threshold and then check for the false positives and the accuracy. Right? Yeah. So I have a table down over here. As you can see, this is my threshold. This 0.0 till 1, and here I have my accuracy, and here I have my false positives. If you have a look at accuracy, the accuracy is low and then it increases up to this point over here, 0.55 or 0.60 threshold, and then it again decreases. While as if you have a look at the false positives, so false positives over here is that it keeps on increasing as my threshold increases, indicating what? that in this use case, because we are looking at credit data, it's probably better to pick a model that has with a lower threshold, because even though it has a lower accuracy, it's fine, right? Because your main part over here is that you're looking at having a small number of false positives. So there's a trade-off between the accuracy and the false positives. You have to decide exactly which is more costly for you, how costly a mistake could be. If your mistake is really costly, then I suggest that you reduce your threshold, else you can pick a higher value. Alright. Now let's just plot the ROC of the true models and check the area under the curve. Model 1 is depicted in green and model 2 in blue. Right. If here from the graph, what you can see is that for model 1, the AUC is 0.84 and for model 2 it's 0.82, indicating model 1 is better, right? Because it has a higher AUC, overall better. But then again, from domain to domain, I suggest that you do check for trade-offs and then decide exactly how you want to go forward. Alright guys, that's it for this video. Thank you so much.